Alrighty, let's get started. Good morning, everyone. Thank you for joining our second Ordr Masterclass. What is the Ordr flow genome and traffic analysis and how to use it? This Masterclass series is brought to you by our product experts to help guide our partners and customers through utilizing Ordr and getting the most out of it. A few housekeeping items before we get started. This webinar will be recorded and it will be sent out to everyone after the webinar is over. If you guys have any questions, please use the chat box or the question box at the bottom of your Zoom screen. We'll either get to them during the presentation or at the end of the presentation. And we would love your feedback, so please take a few minutes after the webinar to share how we did, what we can do better, so that we can make each masterclass even better than the last one. So without further ado, Eric, let's get started.
Sounds good. Thanks, Faya. So I'm Eric Stressenruder. I'm the self-proclaimed product expert, and I'll be going through flow genome and traffic analysis. And what we try to do with these classes is make them brief tidbits of kind of more deeper dive technical information. I'm going to be manning the questions as well as the demo and the presentation. So if I see a question pop up that's relevant, I'll kind of bring it up to the whole group. If I can't get to them because there's too many or there's none, we'll try to save stuff to the end. So if you have questions as we're going through, definitely use the Q&A. Most likely that's allowing me to kind of see things firsthand. So just a couple of quick things. Our goal is to be your partner in cyber resilience, and we're going to help you find every asset that's connected to your network, wired, wireless, and we're doing this all agentless and passive. So that's kind of our goal. And I've just set up a few slides because we do have a mix of current customers, partners, and soon to be customers. So I've got to at least lay a little bit of groundwork of how things work and how things function to make sense as we go through the demo. But the majority of the next 20 to 25 minutes are going to be in our current UI, going through the process procedures of how to benefit from the flow genome. So I want to start here just to and I kind of run these through a 1, 2, 3 kind of steps. We use a sensor, a virtual or physical sensor that's connected to your network. There could be one or more, depending on the size and the scale of your network and your architecture. And that box is really doing all the heavy lifting. It's doing the real-time raw packet, deep packet inspection, retrieving all the metadata, and then feeding that into the data lake. So the middle piece is where most of the smarts are. This is where we're taking stuff in from additional sources, logs, topology, NMS, IPAM, and kind of collecting all that together so that we can extract the key bits to pass that up to our analytics component to do all that real-time classification. We also then do this flow genome. That's the blue piece with the nice big blue arrow pointing down. That's the spiral helix, the DNA kind of icon representing how these devices are communicating. And that's what we're going to spend a bulk of the time. And I'd be remiss if I didn't talk about the point or kind of one of the main benefits of the flow genome is the ability to then do actions. So not only are we visually showing you how your devices are communicating, the ports, the protocols, the timing, we're also allowing you to integrate with tools that you might have to do these real-time actions, firewall policies, NACs, and things like that. The point of doing all this is giving you this real-time consumable metadata that makes sense for what these devices are. So we're going to discover every device that's connected, regardless of off-method connectivity. We're looking at things a lot deeper, and it's we're going to spend most of the time talking about, but the goal is to connect all this deep context on every device. And this could be hundreds or well over 1,000 pieces of information for every device. So it's not just a handful of cherry-picked information. It's deep, rich, valuable information that not only visually looks good, so you can identify what's doing what, but also to feed these into additional systems. So we play well with SIMs and SOARs and tying into your other third-party tools that you might want to take the valuable data that we've been able to clean and extract and feed these into other systems that you have. And ultimately, that results in this real-time behavior profiling. So once we're able to see the flows and the ports and the protocols and figure out what this device is, we can then start to use the machine learning to figure out, should this device be behaving this way? And whether that's a medical device, a PLC, a smart home device, we can classify all this stuff in real time and give you this real-time visibility visually, and then also play into your other components. So the last slide is really talking about the benefits. Visually, it looks great, but it has a lot of content that you're going to get out of kind of using this. And of course, it's really about profiling the devices. So without having kind of like the standard rules that if this, then that, we're doing a lot more real time and contextualizing how these devices are communicating by looking at so many different things. It's not just how they request an IP address, or it's not just that they talk over the internet. It's all those things together, and then using kind of that real-time analytics component to then measure the kind of the classification and the normal behavior that you would expect from this type of device. This gives you real-time anomaly detection, real-time response to malicious events, which I kind of talked about 2 slides ago. Once you now determine that this particular HVAC component is behaving badly, it's one thing to know it and visualize it. It's another piece to actually start to do something with it. So to segment or push an ACL or some sort of firewall rule to segment that device. So all of these things work together. You'll see hopefully by the end of this, kind of going through the demo, that this flow genome and traffic analysis, why visually they look good, they serve a very valid purpose. So I'm going to jump right into the demo. So the demo that you're seeing here, this is our standard deployed product. This is if you deployed it tomorrow, or if you've got it and you're trying to help dive deeper into the product, this is exactly what you're going to see. So the dashboard in itself is kind of the landing page. This is where you're going to see all of the real-time classifications, profiling, OS information, protocols. So all this is being collected in real time, not on a scheduled basis. It's happening live, usually within about a minute. If you have a new device connected, it's going to show up on this dashboard and allow you to interact with it in real time. So when you get this list of devices, and I want to start to dig in, if I want to use facility devices, let's just say for this example, I want to look at my online devices. I can quickly get a table view, a list view of everything that matches that particular filter. So I'm looking at 2,780 total devices that are online and being grouped or profiled as a facility device. And you can see this could be a traffic controller, a UPS, network cameras, traffic sensing devices, lots of information. And kind of what we're going to focus on now is this flow genome. So the flow genome, which is this DNA icon, it's a spiral helix. This represents digging deeper in to the particular flows that that device has. So if you don't see this flow genome icon, that's an indication that we're not seeing enough information to be able to extract the flows. And that's kind of another, something we'd have to look at with you, but you should see with a proper configuration, these showing up. And then to get into the details, you can click on it. I'm actually going to navigate to a Axis camera just so we can kind of filter, and I'm going to sort by risk so we can get a little bit more visually appealing information. So let's dig into one of these. Now, I can go directly into the flow genome for a device if I click on this particular icon, or I can just click on the particular device, see the relevant metadata that we've identified and exposed in the UI, and then there's a particular tab that you can go to. So this flow genome tab, when you click on it, it's going to populate with the records that it's been able to collect. Now, this data that's collected here is stored almost indefinitely, right? There's some database size and scaling, but you can kind of look at this from the time the device connects to sometime in the future. We're allocating and associating all the particular flows or the exchanges that are happening between that end device and any other devices it's communicating with. I still have spent over 20 years in law enforcement, so I'm going to use a lot of analogies that I think a lot of people will connect with. Even if you're not in law enforcement, most people love law enforcement shows, the crime shows. And I like to break flow genome into what I call the footprints. How the devices are communicating. If we're trying to profile, is this a device, a Nest thermostat, or is it a VMware workstation? How it's communicating is the fingerprint. That's going to be unique to that particular segment of device or type of devices. The flow genome, I call it the footprint, because this is where it's been. So if you show up and you're trying to track down, who climbed in this window or who did what, you're going to start looking for evidence. And this is kind of the digital experience that you're going to have when you're tracking down what a particular device does. So this flow genome, looking from the top down, essentially on this helix, is grouping things based upon risk at first, and you kind of have a way that you can adjust from severity, diversity, size, and recency. This is breaking down, if we start from the top, this is a particular P5624 axis camera with this IP address. There's 10 unique communications, and it's different from the flows. So if you look at the flows, there's 18. So the 10 is an indication of this source talking to 10 other unique destinations. And within those destinations, there's 18 flows. So you'll see as we kind of go through some of these, and I'm just selecting them to see the different bits of information, some of these, or at least one of these, is going to have more than one flow. So here's the one here. So there's 4 particular flows. So that's a clear indicator that this device is talking to this 10.138.88 address, and it's has 4 different types of communication. So the first one, if we kind of look through some of the data that comes back, it's talking on TCP port 80, it's going out. If we look at the second one, this is an inbound communication on TCP port 80. Number 3 is a separate RTSP stream that's going out. And then the fourth one is there's an inbound on port 50,006. You can also see there's a reference to the number of flow occurrences. So we're tracking all of this as it happens. The more chatty the device, the more flows that we're going to have. So if you use an example of a phone, a mobile phone, they're going to communicate with a host of services. It's not going to be 3 or 4. They have hundreds because of all the real-time push information that's coming from Apple or Android or whatever it might be. But this kind of table to the right, or this setup to the right, is a good starting point if you're trying to figure out, if you know you have an IP address, you can go figure out very quickly who that device is talking to. So the top part is kind of the extracted attributes from that. The table just below, which is a Sankey chart, this is just showing, if you look at from left to right, this is the end device. So on the left, this is that 10.36.101.223. You're going to have 10, so there should be 10 particular endpoints here, because that's the number of communications that are happening between source and destination. And then you're going to have whether it's intranet or internet. So is it going outbound or staying local to your particular site? And then the classification on the severity. So is it a high event that has happened versus a low event? And you see, as I select, the behavior state is showing up above. So if I've got a normal flow, there's going to be a behavior state of normal. If I have a high or medium flow, I'm going to have a behavior state that's changed. This is the Ordr security piece that's looking at the real-time communication. The real-time communication is many different things. It's internal communications, how they're communicating east to west between a workstation and a server. Is that normal? Is it opening up a bunch of ports? Is it scanning ports? You would see all that here. So if you fired up a network scanner, you would see all those ports and protocols being queried in and out, as well as external. So is it going out to the internet? Is it going to a known malicious site? Does it have a command and control connection out somewhere? So these are the things that you will see, and we will do a masterclass separately on security and the security tabs, but this is just one piece that you're going to use to build that evidence portfolio when you're tracking and doing these digital forensics. So someone has asked, and I'm just going to bring it up because it came up now, are these real-time sessions or historical? And the final piece is they're both. So it's going to show you anything. So it's near real time, so within about 60 seconds. And we will show you first seen and last seen. It's not going to break down every single flow with the timestamp on it. It's just going to give you the first and last and any of those number of flows as it happens. So you're limited on some kind of the user experience and user interface with too much data. So we're trying to give you the valuable components that you need that are going to help in either just investigation or acknowledgement or feeding stuff into an additional system. You can also see that from the flow genome, we break down internal and external. So external, public facing. Sometimes people say, well, what if I've got assigned IP spaces that are a public space, but they belong to me, to my company? We give you the ability to define that in our config. So if you have a public space defined to your company, facility, whatever it might be, you configure that, and then we will mark that as internal. But otherwise, if it's a public facing IP, it's easy to kind of break those down. And you'll see as I select external, the Sankey chart below only references that. And the same thing, if I select internal, you can see it's just the internal communications. So from here, once I'm in this flow genome, the other piece is I might want to see this textually. I might not want to look at charts and graphs. I might be more interested in ports and protocols that I can sort and extract and filter. So if I'm just going to set this back to all 10 so you can see it, you've got this icon above where you can view the flow list textually. So if I click that, it's going to change and show me everything kind of in an Excel format. The nice thing about this here is there's a couple of things. If you wanted to share this with someone, these 18 flows, you have the option to download. And in most of our screens, we give you this quick download in CSV format. Might be good to share with a partner or somebody else that you're trying to validate. You can also do many actions from in here. You can see these are not baselined. We can baseline traffic automatically or allow you to manually classify. So if I want to take these 18 flows and I want to perform an action on them, I can select any number of them that I want. So if I'm just unselecting 2 or deselecting 2 just for the point here, and I can add these to the baseline flow. Now, what that means is you are manually telling our system that this is expected traffic flow. If it falls outside of that, that would raise a behavior violation, which you'd see in the security panel, as well as you do below down here. So now that I've marked these as baseline, I can start to do some enforcement. And we're not going to go through the kind of the rigors of segmentation, but this is definitely plays along very nicely with the flow genome, that now that I've marked these 16 policies for this particular device, I can start to perform actions on these. So I could go in and say, let's enforce these at the firewall. Let's generate a CLI command based upon your particular vendor, Checkpoint, Fortinet, Cisco, you name it. You can generate the particular setup here and copy and paste this for change management to send to the network, the security team, what have you. So this is just the natural progression. We'll do another masterclass on segmentation and kind of the functions and the flows of how you'll do that with an order. But we've made it so simple that you can do this from an individual device level. So I can enforce policy directly on a device, or you can do this at the group level. So you can look at flow genomes, at how they apply on an individual basis or on a profile basis. Now, just another kind of segment for this piece here is these flows will change based upon the device, right? So if I select a different device, you're clearly going to see this one's got 11. They're all going to give you interesting pieces of information, whether it's helping you to isolate, remove, or interrogate other devices. This is happening all the time in real time. So it's giving you real-time visibility into how things are communicating. This plays in very nicely with our traffic analysis piece. The traffic analysis is another representation, and this is, I'm going to go through a couple of these so they make sense. These are 3 concentric circles that are representative of the types of traffic versus the types of devices that you're communicating with. So if we look kind of from the outside, I'm going to expand this just a little bit so everyone can see this easily. The outside circle is representative of the internet. So this is talking out to public sites, good sites, bad sites, social media sites, malicious URLs, you name it. The next concentric circle is depending on which one you have selected from the left. I'm in classification. So this is going to be profiles. So the different types of devices. So if I want to see where my retail devices are communicating, I can isolate just to that group. And then the inside circle is representative of intranet traffic. So things across your local network, and you'll see servers and multicast broadcasts and authentication servers. The nice thing about this is you can start to really get very granular, or I can look at the big picture. So what I've done now is I've selected the entire internal concentric circle, and that's given me this list over here. So I can tell quickly who's my chattiest of the groups, and it's local IPs talking to servers, right? That's probably expected between backups and what have you. But if I move out to the device level or the classification level, the busiest communication point is between workstations and network devices. If I move out to the internet and click that line, public US to workstations. So again, this will show up based upon your traffic flows, and everything's going to be different based upon the traffic that you have going through. But this traffic analysis, sometimes we refer to it as a constellation diagram, gives you the ability to segment and see visually how your devices are communicating. And I can quickly look and say, hey, who's talking to, a public AV server? There's a workstation. And then you've got this line. If I click on the line, you're going to notice a very similar pattern of a Sankey chart up above, kind of showing it's reversed now. So you've got the external piece talking to the internal piece. And I could do the same thing. I could look at this textually if I want as well. So this gives you the ability to look at the classification flow versus just an individual device. And then the same thing goes for these additional components on the left. So as I move from classification, which is group-based or profile-based, I can look at how my VLANs are. So all of the same thing on the outside, the same thing on the very inside. What has changed is the middle component. So each of these is representative of a VLAN. So I could do the same thing. If I make this large and I click on the line itself, I can see my heaviest chatter on the VLAN side. And the same thing would go for the subnet. This is just breaking down subnets. So if we're only seeing layer 3 traffic and we don't have VLANs, what have you, you can look directly on the subnets. The last piece, if you're on the medical side, we give you even more granularity on the individual component. So as I hover over each of these, point of care analyzers, patient monitoring groups, and as you click on those, it's showing where they're communicating with. So again, this is building from, we see traffic, we discover what it is, we classify what the device is, we create this baseline flow, but then we give you this really nice multiple options for visualizations into how the devices are communicating. So you can, even if you're not a network person or a security person, it's pretty easy to say, hey, which of my devices are talking to social sites, right? I've got a handful, a CT scanner and a PACS that's talking to social sites. Maybe acceptable, might not be. We've got a time check. We've got a couple more minutes, and we've got a few questions that has come in. So can nodes be added to a circle? The answer to that one is soon. We will have the option to add through a configuration file additional. So if you see some of these, Ryuk and ransomware and Revol, these are examples of us giving you the flexibility to add these kind of nodes on the outside. So absolutely, that's coming. And then the same thing in traffic analysis. So I think Corey was asking about these nodes. So yes, you will be able to configure any unique destinations. So if you want to track if certain devices are talking to an external or potentially an internal set of nodes or devices, you'll be able to customize how those work. And yes, Corey, that will apply to essentially the outside or the inside circle. The middle circle is either devices, subnets, or VLANs. So those are kind of fixed based upon the traffic, but both either side of the concentric circles will be configurable on who's talking to who. So kind of just as a quick recap, all of this flows through all of the data. So, we're not talking about the dashboard, but the same process. Traffic feeds in to the particular sensor or sensors. The data is aggregated, extracted, analyzed in real time, and then presented in kind of what we think is a very appealing visual way. and you'll have these abilities to look at flows based upon profiles, which I can show you here. This is a profile-based flow genome as opposed to an individual device's flow genome. There's 12 records here. So it's aggregating the flows across all of the devices that match that particular profile. So in a very chatty type of device, this could be thousands of flows. So you can see what's the pattern, the commonality amongst those flows, way down to, individual traffic analysis based upon the specific piece of information that you're looking for. So I think that's most of the questions, and we're going to keep doing these master classes. If you've got feedback on anything in particular, new items, I think you'll see we're building these to help kind of dig in deeper where necessary to help you focus on what's going to make things work better for you in the Ordr platform. So please make sure you tune in next time for the next masterclass, and I appreciate you guys taking the time to join.